Okay, this is the Voltaic electrochemical cells experiment, and part A says to construct a salt bridge by completely filling a U-tube with 1 molar sodium nitrate. So I'm showing here the U-tube of glass. Okay, and then I have my solution that is 1 molar sodium nitrate, and I would completely fill this U-tube with the sodium nitrate, and then I'd use these two little pieces of filter paper and stick one in on each side and hold them with the corks. So I'm just going to show you this, and I am going to use this one that I prepared earlier. Okay, so this is the U-tube, the salt bridge that I'm going to use. Okay, part B says use of the voltmeter. So our voltmeter should be very familiar to you. It is essentially our pH meter, except in this case I'm going to use the setting not as pH, but I'm going to set the setting to millivolts. Okay, and then instead of hooking up a pH probe, I'm going to hook up these 2 wires with red and black leads that end in alligator clips. Okay, so that's going to be our Voltaic cell voltmeter. Okay, then it says to prepare the electrodes. So we've got a set of 4 electrodes for the first part D. Okay, and each electrode, right, is these pieces of metal. So I've got a copper strip and a zinc strip and an iron nail, so that'll work for that. And for the 4th one, we are going to use a pencil lead, okay, which is not really lead, it's graphite, but it does conduct electricity. So we will use one end here, we'll clip the alligator clip to the other end of the graphite pencil, will go into our beaker. So we've got 4 beakers here to put our solutions in. So each electrochemical cell, or Voltaic's electrochemical half cell, will be in each one of these beakers. Okay, and so I'm going to pause it, and then we're going to get those set up. Okay, so I've put the solutions into the beakers. So solution 1, or half cell 1, is 1 molar copper nitrate. Okay, and so it's a nice pretty blue color. And that's where the copper strip will go into. So we'll put that in there. So that will be our 1 half cell. Our second half cell has 1 molar zinc sulfate, and we've got the zinc strip, and so that's a colorless solution. So we'll put the zinc strip in. The third solution is 1 molar iron sulfate. Now this one, it decomposes pretty quick, so you have to make it up fresh every time you use it. So I made up some iron sulfate for us, and it's this lightish green, as that's what it's supposed to look like. As it decomposes, it'll turn to a rust color, because it'll go from iron 2 to iron 3. So we can use it as we go. And we've got our iron nail, so we're going to put that in that one. For the 4th one, the 4th cell, cell number 4, half cell number 4, we're going to make a mixture of both iron 2 and iron 3. So we've got 8 milliliters of the green stuff from half cell 3, so the same iron sulfate, and then I have some 1 molar iron trichloride, which is iron 3+, and that's the kind of a characteristic kind of rust colored. And so I'm going to dump both of those into the same beaker to give us half cell number 4. Okay, and that cell, that's where we're using the pencil. Okay, so we got the 4 half cells, and then we're going to start to hook them up. Okay, so we're ready to start our measurements for our different combinations of half cells. And so we're going to start with half cell number 1 and half cell number 2. That's the copper half cell and the zinc half cell. And if you look at the table on the report or in the experiment, it says that the copper is the cathode. Now remember, for our two leads, we have to hook the cathode to the red lead and the anode to the black lead. Okay, so we're going to hook those up, and you can see our voltage reading over there. Hook the red and the black, and you say, okay. Whoop, I was going to flip over on that. That's okay. All right. So you're saying, well, wait a second, why can't I get a nice stable reading? I've got it hooked up correctly, but we are missing something. We are missing our salt bridge. So I'm going to put the salt bridge in, and we're going to see what happens. We should be able to get a good reading off of that. Okay. So you can see the reading for this combination is 1,134, and that's in millivolts, or 1.134 or 5 volts. Okay, so this first combination, they told us, we knew which one was the anode and which was the cathode. But I'm going to switch these around so you can see what happens if we got these backwards. So I'm going to hook the black one over onto the copper, and I'm going to hook the red one onto the zinc. Okay, get the cord out of the way there. I can. Stay on in there. Oh, alright, so I'm going to get this clipped on here a little better. Okay. So now if you look at the reading, you can see, maybe, if I can get this to be in there and not in the way, you can see it's a negative value. Okay, it's a negative value. So instead of a positive, you get a negative. So for all the rest of the combinations, we need to note what the voltage is, but we also need to know which one is the cathode and anode. Okay, and if we get it wrong, if it's a negative, then all we have to do is switch the two leads to get the correct. If it's negative, it's running as an electrolytic cell, not a voltaic cell. Okay, so we're going to switch it back just so we make sure we have the correct reading for this first one. Okay, so we're going to put the red one back over here, making the copper the cathode, and then I'm going to put the black one on the zinc. Okay, now it might be a little different than before. It's partially because of the salt bridge and this kind of thing. Okay, but there's a reading here for the first combination. All right, so now I'm going to take the black lead, the leads off. I'm going to take out the salt bridge because I need to rinse off the ends of that with some water. Okay, I'm going to remove half cell number 2. I'm going to put in half cell number 3. Okay, so I'm going to stick the salt bridge back in here now. Two sides. I'm going to hook it up. I'm going to put the cathode on the copper just to start with. We'll have to see if we get if we get a positive or negative number. I'm going to hook the black to the iron nail. Okay, that's going to okay, come on. Alright, sorry. We have to get this to stay in there. We're getting a positive number. Okay, which means we've hooked it up correctly. Okay, we'll see if it kind of stabilizes. The iron one sometimes doesn't. We'll see if we can get it to stable. Okay, I'm just going to have to hold that. Okay, so that's going to be about what we're going to get. It's about 730 for that one. And note, remember, the half cell 3 was hooked onto the black, so that was the anode. All right, so we're going to move on. Take this out of here again. Rinse it off. cell, remove half cell 3, and put in half cell number 4. Okay, so again, we'll put the salt bridge in there. Now I'm going to hook this up to the graphite. Okay, so if you can see the value there, it's a negative, which means I've got the cathode and anode reversed. So before I take my reading, I'm going to switch the leads around. I'm going to put the red one over here on the half cell number 4. Okay. And the black lead onto the copper. Okay, so now we've got a positive value. And there it is. Okay, so you can record that. Alright, so that's all the combinations with half cell number 1. Okay, so we did one with 2, and one with 3, and now one with 4. And so now, I'm going to move 1 out of the way, bring half cell number 2 back, and we'll do 2 and 3. Okay, 2 and 3. So that's the zinc with the iron 2+. And stick the salt bridge in there. Again, we don't know which one's the cathode or the anode, so we can just choose to start with. I'll put the red one over here on the iron, just to start with. Put the black one on the zinc. Let's see what we get. Hey, look at that. We got a positive value right off the bat. Okay, so we got that right. So this time the anode is on the zinc. The cathode is the iron. And you can record that value. Okay. Alright, so we did 2 and 3. So now let's do, we'll have to do 2. And we'll move 2 with 4. Okay, so I just left the black one hooked up to the zinc because again we don't know what's what until we try it. So I'm going to hook that in there. Now we're going to hook the cathode to this one. Hey, we got another positive value, so this is a good voltaic cell. And the anode, the black lead, is hooked to the zinc, and you can read off that amount of millivolts for the combination of 2 and 4. Okay. And now we've got one more combination left. All right. We did 2 and 3 and 2 and 4. The only one we got left to do is 3 and 4. Okay. I'm going to get my nail here. I'll hook that one to the black lead again, just to start with. And this one to the red lead. Okay. So we were lucky we got a lot of them on the first try. We didn't have to reverse it too often. But this is the millivolts for combination 3 and 4. Okay? And it's, hopefully it'll stabilize. That's pretty good. Okay, there's always a little bit of moving on this. Okay. Okay, for the next part of the experiment, we're going to use a bunch of copper half cells, but with different concentrations. So we're going to still use half cell number 1, and remember that one was with the 1 molar copper. And then we've got 0.1 molar copper, 0.01 molar copper, and 0.001 molar copper solutions. And so there's the 1 molar, 0.1, 0.01, 0.001. And the reason I put a white background here is you can see the color gets a lot less blue as you go. And for the electrodes for this part, we're going to use copper strips for both half cells. Okay, so we're now ready to do the second set of readings for the Voltaic Cells experiment. We are now doing 2 different copper cells with different concentrations. Okay, so we got copper cell that we did used number 1, which is the 1 molar, and this time we're using the one with the 0.5, number 5, which is the 0.1 molar. Again, I'm going to need my salt bridge, so I'm going to put that in here, and then I'm going to hook up the black and the red leads. This time we've got it, both are copper electrodes, so I'm going to hook. This time when you report which one is your anode and which one's your cathode, you can't just say copper, you have to say which solution concentration is running that. Alright, so let's see if we get a positive. Nope, we got a negative value, which means I've got them hooked backwards, so I got to reverse this. I'm going to hook the red one over here, and the black one over there. Okay, that's going to flip around, that's okay. Alright, so, there you go. There is the, you can read the value of the millivolts, and the black lead is hooked onto the half cell number 5. Okay, and you can record the amount of millivolts for that one. Alright, so I'm going to now take this one off, and we are going to rinse off at least that side of the salt bridge. We're going to remove half cell number 5. I'm going to take the copper strip out and rinse that off as well. And we're going to put in half cell number 6. Okay, and I'm going to put in the electrode that I rinsed off. Now I'm going to connect this. And again, we're missing our all-important salt bridge. Alright, and so you can read off, okay, let me get the cords out of the way if we can, and you can read off the millivolts there, and you can see that the black electrode is going into half cell number 6. Alright, we got one more reading to take. Rinse off the electrode again, and rinse off the salt bridge. And take out half cell 6 and put in half cell lucky number 7. Put that back in. Okay, put our electrode in there, and again we're going to hook that one to the black one. See what we get. And you can read the voltage there. And again, when you have combination 1 and 7, okay, you can see that the black lead is in half cell number 7, and the red lead is in half cell number 1, and you can read off what the voltage is there.